Okay, what just happened? So, Gerald, has someone joined our meeting? Oh, Gerald has left. Okay. All right. Now, according to you, or let me reduce a few tables, a few columns. Delete that so that we don't get confused. Delete that. I have three. I've just remained with three. According to you, which one is a non-key column? Non-key, meaning that column which, even if I'm given that column, I cannot be able to tell something out of it. I see Jacqueline. Wow. Kimberly as well. Hey, yeah. I'm telling you, today's class, I feel like just ending the class because you guys are already ahead. Hey, how did you guys know that? Like, yes, it's office location. So I can see you're already aware. It's like I'm touching things that you guys have already gone through it. Yes, office location is a non-key, right? Meaning, even if someone gave you an office location column, you'll not be able to tell, like, okay, so what can I be able to use this column for? It does not identify anything. So when you say in second normal form, it should not have partial dependency, meaning, okay, open your ears now, meaning, you see this column, it depends on what? A non-key attribute, which also depends on the primary key. So what will happen here is we'll have to break this table into two. You see, which you're going to see when we get to the hands-on. So number one, we ensure there's no partial dependency. Okay, so we remove non-key columns. Okay, meaning there's no partial dependency. That is what we mean by partial dependency. Okay, so by partial dependency is, I can see guys are saying repeat. Okay, so partial dependency is for this office location, it depends on what? Department, right? So meaning we need another table that tells us more about departments. Like even if I'm given this column, I cannot be able to tell where this office location is. So meaning we need another table, right? We need a different table that will hold department information and a separate table to hold employees information. Yeah, so we break them into two. That is how normalization is being achieved. Great. Aya, let's go to now the final one, that normal form. So we say for a table to be in that normal form, first of all, what it has to achieve, it has to be in the first normal form and second normal form. Okay. And it doesn't have to have what you call transitive dependency. I want this to sink in. So what do I mean by transitive dependency? I don't know if all of you did physics in high school. Um, how many of you did physics? No, we are not learning physics. I'm just trying to see how many of you learn physics, transitive law physics. So what do you mean by transitive law in physics? Let's see. Okay, so if A is equal to B and B is equal to C, then A is equal to C, and then this is transitive. Okay, this looks kind of complex. Let's try to see how we can be able to summarize it into a way we can all understand. Okay, I can see when we're talking about physics, it's not quite a cup of tea for many. All right, let's come back to SQL. Now, um, when you say transitive, okay, check a pen, take your pen now, write this down. What you mean by transitive is when a non-key depends on another non-key attribute, which in turn leads to a transitive dependency. Let me give you with a drawing. Okay, let me show you with a drawing. I'll call this student. And then I'll call this student ID, student name, subject, subject ID. I'll add another one. Subject, name, and then address. So, according to you, which two columns, they do not talk more of a student? Which two columns? Like, even if I remove them, still I can be able to remain with a table that tells me about a student. Innocent, that's amazing. Grace, that's amazing. Um, okay. Now let me tell you. So, what do you mean by transitive? Okay, look, pay attention now. Stop diving. Pay attention now. Please look. You see this? This is a non-key, right? It depends on what? It depends on this one, another non-key, which again depends on. Okay, let me pick a drawing. So this is a non-key, right? Meaning it has to depend on this one, first of all, and then this one depends on that one. What this means is transitive. This is what you call this thing is harder to write with. Transitive. Yeah, I've tried my best to write with it, but you get the point, right? Of importance is you understand. You see, this is a non-key. This is not a key, which also depends on another non-key, which again depends on a key, a primary key. You see, a non-key depends on another non-key, which rather depends on a key column, which now this motion is what we call transitive. A non-key is, what I mean by non-key is that column which is not a primary key. It's that simple. Let me even tell you. A column that is not a primary key. A column that is not a primary key. Even if it is removed from the table, I can still be able to uniquely identify a row. Good. I can see guys are asking, is subject ID another primary key? No, because if it was, I could have written primary key over here. You see? Yeah. Are we somewhere? Are we good? Do we now understand transitive? All right. Now, there's something that I'd skipped. Okay. I want us to go back a little bit. Let's go back a little bit. So there's also BCNF, okay? In reality, okay, in reality, in your life as a developer, you'll have to normalize the table until to the third normal form. So where do these other ones come into play? Listen to this. BCNF is a strict version of that normal form. What do I mean by that? Meaning this one is a strict version of this one. What it addresses is addition anomalies when you're trying to insert data. Is a strict version of that normal form that addresses additional anomalies when you're trying to insert data. We have the fourth normal form. What does a fourth normal form do? It is used for multi-valued dependency, meaning I think it's complex relationship, like foreign keys, handling complex I hope this thing can be seen, complex relationship between table. Okay, I can't write it with it very well. I don't know how to write with it. So what we can use the fourth normal form is used for multi-valued dependency. Write this, multi-valued dependencies. And then we have the fifth normal form. Fifth normal form. I believe everyone remembers join, right? We covered joins last week. So how does the fifth normal form help us? So what it does is it addresses the join dependencies. Now this one is only used, again, underline that, only used in specific scenarios. But I've said what? In reality, you'll use the first, second, and the third. I'm not saying that you'll never come across this. You might or you might never. But in reality, you'll be using the first, the second, and the third to ensure your data is normalized. So this one handles what? Joins multi-valued dependency or multiple multi-valued dependency, and then this is a strict version of that. Great. It is as simple as that. Now I think we are now ready to get someone to read for us checkpoint question, and then we can go to the hands-on, and then we can call it a day. As I said, today's class is going to be short. Also remind me towards the end to release the open source repo for you guys to just participate in, and then I'll tell you the guidelines towards the end. So Samuel, read for us the checkpoint question.
Checkpoint questions. Why do we need normalization in DBMS?
Yeah, why do we need normalization in BMS? Kimberly, that's amazing. You deserve that. Fariz, amazing. Sharon, Ian. Okay, read for us the second one.
What are the different normal forms in DBMS?
Yes, what are the different? Hey, Liz Penza. I hope I'm reading your name correctly. Pascalia. Wow, you guys have amazing names. Julius, Jacqueline as well. Read for us the third one.
What are the non-key attributes in a table?
What are non-key attributes in a table? Hey, Gideon. What are those, Gideon? To be honest, Gideon, I did not say those ones. Hey, Gideon. The way we've taken so much time to explain those ones. No, I did not say those ones. So what are non-key attributes? Non-key attribute in a table. Amazing, David. David, you deserve a drum roll for that. Victor. Impressive. Now, what we'll need to do is, let's go to now the key takeaways. This is the time we now carry the key home. Okay, let me pick the Maclean, lady and the gent. Okay, yeah, the Maclean, read for us. Time to carry the keys home.
Key takeaways. By identifying entities and relationships early, you can structure your database to avoid redundant and inconsistent data. Applying normalization techniques, first normal form, second normal form, third normal form, helps eliminate data redundancy and ensures data is logically and efficiently stored, reducing anomalies. In first normal form, we eliminate repeating groups and ensure that each column contains only atomic values. Second normal form builds upon first normal form by ensuring that non-key attributes are fully dependent on the entire primary key. In third normal form, we ensure that non-key attributes are only dependent on the primary key, eliminating transitive dependencies.
Amazing. You deserve a drum roll for reading for us. Thank you so much. Now, what I want us to do is dive straight into the hands-on repo. And then after doing the first one, the first normal form, then we're going to take a quick 5, right? Yes, let's now first do the, I believe everyone has access to this, right? No. Okay. Let me share the link again. So once you access, open week 6, this one, and then init.md. So we're going to start off with the first normal form. What I also want to do is open my SQL Workbench as well. So just as usual, use sales DB. That is the first thing. And then I want to design a table. Okay, before we come to all these examples, I want you to ensure that you guys understand this. Okay, so I'm going to design a table, and then you tell me what is wrong with the table. Okay, so I'll start from the concept, right? Remember, we start from where? The concept. Now, I'll delete this column, or I can just create another one. I can say student name, their age, address, subject. There. So I want us to create something like this, exactly the way it is. All right? Because these are the common mistake that people do when maybe trying to design or come up with a database. Is it visible? I want something that is it visible on your side? Out there. Perfect. That is visible, right? Amazing. Now, design the same way I've designed mine. Now, come here. So create table. So I'll start by writing create table, right? Students, open that, and then say your students. Name. I'll say this is Varchar 100. This subject as well. Right, Varchar 100. Their age is gonna be integer, and then address. It's going to be Varchar. So if you're experiencing any error, remember to share the screenshot in the Padlet. All right. Yeah. So you're going to see the link to the Padlet in a few. There. So please copy whatever is on your screen. All right. So we can proceed. We try to insert data just the normal way you usually insert. I think we have a student in the sales DB, but I'm not sure. But if yours says, just drop it because we don't need it there. Just drop it if you have. Yeah, drop it and then create a new one, the way we are creating ours. The address is maybe Nairobi. Just insert some random data the same way I'm doing mine, and then I'll explain to you what's happening here. So allow me to just increase the font size. Just insert some random data. What I want you to do is insert random data. So I'm going to change here to Lagos. 21, maybe 22, Cape Town. I'll call this one Mary James, or Mary Jane. I'll call this Brenda. Lerato. So all of them are checking that. Now, that is what we have as per now. Okay, believe it's now visible on your side. Or let me just reduce this there, so you can be able to see it, right? Just execute, and then we try to fetch the table. Great. Now open a new working area, and then select all from students. If it says student table already exists, it's because in that table you had a student table. Now, guys, you can see that's how the table looks like. So let me open the charts and then tell me what is wrong with this table. Yeah, let's engage in the charts. What is wrong in this table, the way it looks? Oluwagasen, no unique value, no primary key. No primary key does not have primary key. Use ID for reference. Amazing. Eugene Onyango, Oluwagasen, Collins. Wow, you guys are giving me suggestion. Like, I feel this topic is way easier for anyone. So normalization, it's not something new. It's something you've been doing all along. It's only that you did not know what you're doing. You're achieving normalization without me having to mention to you. So by the look of things, this table has already violated the first normal form. As I said, we cannot have a cell storing multiple values like this in a list. There should be what? Each cell should store one atomic value. Like if it's math, it is math, chemistry, chemistry, not multiple like this, math, chemistry, whatever, whatever. It cannot hold multiple values. Atomic, it should be single. Also, it has violated the first one in F because how can I be able to identify this is John Peter? There's no unique identifier. Like we don't have unique identifier, which is the primary keys, meaning there's no consistency and we have violated data integrity. Do you now see how normalization come into play when I was telling you about the importance of normalization? So, meaning if you do not understand how to design a table properly, it will affect you. Right? So if I was this person, I know this is Jonte Fresh who designed the table. So how should Jonte Fresh be able to design this table? Let us discuss so that we get to understand how simple this concept is. Let us discuss how can we be able to design this table so that we get something concrete out of it. We should break it into two. Hey, Florence, let me even clap for you. Hey, Florence Achieng, that's impressive. Hey, I'm so happy. My learners are this smart. Hey, today I'll sleep happy. You guys are smart. Now, we break it into two. Hey, Florence. Hey. We break it into two. Meaning, I'll have another one that stands for subject, right? And then I'll start with student ID, right? We can now have here, so that we make a reference, we use subject ID. So here, what you need is just subject, subject ID, subject name, like that. Now, let me ask, what type of relationship can be achieved using the student and subject? What type of relationship? Like last week we talked. Wow, Abel. Hey, today you guys are making me so much happy. Like you guys are this smart. So one to many. It's simple like that. Like I told you, it's something that you've been doing. Only that you did not know what you're doing is you're actually achieving normalization. So we bring this guy over here and this one over there. Simple like that. Are you seeing something? Are you guys seeing something, or is there anyone who is lost what we just did, or whatever we did was just magic? Is there anyone who feels like we've done magic? No, we've not done magic. What I'm trying to show you is that when you try to design a table and then you don't consider things properly, it's going to affect you as a database administrator. You're saying I've put what? The arrow the wrong way? Nah. What happens is, where we are referencing, meaning this is a foreign key. I need a text. We use what? One to many, like that. And as well, we'll use what we call a foreign key. Okay, just draw them on your paper, on a paper, sorry, and then maybe you can practice later. So it is not wrong. The reason I'm saying it's not wrong because it's the student who's referencing the subject they are taking. Because a student can take math, can take chemistry, can take as well what? Physics, biology, all that. Right? One to many, one to many. So now that you guys are aware, it's time to clean up Jonte Fresh mess. How do we clean up now Jonte Fresh mess? First of all, what we need to do is drop. I told you, this one you'll never leave it. DDL, DML. Like if it's a song, if there's a song I've been singing from the word go, DDL, DML. Like that one, you'll never leave them. You'll never, ever, ever, ever. DDL, like you need to write this somewhere. Where you're sitting right now, if there's a wall, you need to stick it like DDL, DML. Drop, table, student. Oh, let me ask now. Where does the drop command fall? Is it under DML or a DDL? Huh? Someone has said DML. Who's that? I need to come with whips now. Let me see if I can get the whips. Hey, who's saying? Who's that? Okay. Now we've deleted it, right? So it's time now we start designing the table properly. So since it's here, I can just remove all this value, right? And then we add a student ID is gonna be integers, it's gonna be primary key. Do you now see why? Do you now understand why every time I'm creating a table, I always start with having primary key? By doing that, I'm already achieving first normal form without even thinking. You see, it's not something that you love to be considering like, is it first of all in the first normal form? Let me see. No, like just the normal way you've been doing it, right? Only that you did not know whatever you're doing, you're achieving the first normal form. Yes, you can even add the auto increment, the plug auto increment. Of importance is the table has a unique identifier. A unique what? Identifier. Also auto increment. Student name, subject, we remove this one. This one needs to be in a different table, their age, whatever. There we need just a subject ID, which will be integers, right? And now we say foreign instead of foreign key subject references subject ID like that. Let me remove that. So meaning I also need to create a new table here. Create table subject subject ID gonna be integers, primary key, all that. And then we have the subject like that. You see, like that. Anyone who's still confused with whatever we just written? Anyone who's not seeing anything making sense? Anyone? Anyone? I mean, type in the chat so that I get to know. Don't write no, you write like, why are we writing it as subject name instead of just name? Good. Now, why is subject name a primary key? Why is subject name a primary key? Which subject name are we written as primary key? Huh? Which table are we reading? Which table are you reading? I want you to read the table that is on your screen. The subject of student ID, student name, age, and the address. And then you have subject ID, meaning this subject ID, let me just draw something here. This one is going to make a reference to this table. It's going to make a reference. Like that. Is that now more understanding? Make a what? Make a reference. These are two different tables. Which one? As I said, why I've written this as 100 and this one 20. Now this is you as the developer to decide. You can even change it to 50. Okay? No one is coming to tell you, you must write the same way I'm writing. Write to 10, write 5, write 1. Oh, I space for clear. Okay, there's the guys who are saying they have to squint their eyes. All right, I'm sorry. I'm really sorry. So this is the student table. Like it's something simple, something you've been doing, only that you did not realize, oh, so when I'm doing this, I'm achieving first normal form and I'm applying normalization techniques. Nice. I love your question, Sharon. So what we are aiming is, what I'm trying to teach you with this normalization technique is, I'm trying to show you when you design the table wrongly, how it's going to affect you. So we can now create there. So we have two new tables right now. We have the student and the subject, right? And the subject. So we can even now try to insert data into student, just one, or the subject. Let's start with the subject. Insert into. Sorry, the subject. Let's start with the subject. Like that. Subject name. So I'm writing just this short name. Bio is biology, like that. You see? And then we execute. We can try to fetch again. You're going to see all that. And then we also insert now into the student. To student name, age, address. And then subject ID. So values, number 1, John Peter. Their age, 20. Address, Nairobi. Subject ID, maybe they're taking math as number 1. All right. And then I'll just repeat this. They live in Cape Town. And then maybe one, they're also taking mathematics. So we are good. We can now execute this. All right, let's try to fetch the student. Uh-oh, what just happened? What just happened? Let me see. Do we have an error? Okay, there's an error. Column count does not match. Did I add extra columns or what just happened? Let me try to debug slowly. So age, address. Oh, okay, I see now where. There. That is what was missing, the age. And just confirm. Yeah, that is what was missing. There, at least now you see the way it should be stored like that. You see? So even if I have to store again John Peter, they'll have a different subject ID. If this ID number 1 is for math and they also want to take chemistry, I'll need to insert again John with chemistry, meaning they're taking multiple. You see? Something like that. You see how simple the first NF is? Let's do another example, right? You guys want another example? All right, all right, all right, all right. Okay. I have so many examples. We can work on this one. Okay. I'll hide this because I still come back to them, all right? I'm just going to place them there. Let's design a library. Okay, I know most of you don't like visiting this, or who lives near a library? Anyone? Anyone who lives near a library? Is there really? Wow. Hey, hey, you guys love reading, eh? All right. So we can have IDs and then the title of the book that you want to borrow and the borrower's name, borrowers. We can just leave it like that, right? Let's see with this kind of example, right? So what's gonna happen? Let's create our table. What I'm trying to show you is by designing things from the word go the wrong way, it's how it's going to affect you, right? Yeah, so library table. Create table, library, open a bracket, ID is going to be a primary key. We forgot to include the data type, which is going to be integers. And then auto increment, comma, the title of the book the person wants, Varcha. Varcha, that, like that. So let's execute together. Let's execute now together. Have you guys written? Have you written whatever is on the screen? Execute. Refresh, just confirm it's there. Library. Here it is. All right. So let's insert a few things on this table. Insert into. Okay. Maybe today I've woken up, I felt like reading. I've heard my friends talk about this book. Which book should we quote here? Gifted Hands. Hey, Nzinsa, Mwanzisa, Mwanzia. It's too early. I don't want chaos. I don't want chaos. Me, I don't want to fight people right now. I don't want chaos, me. So I'm going to write simple books here. I see you guys want chaos, eh? It's too early for blood right now. Okay. Gifted Hands. I think this by Ben Carson, if I'm not wrong. Gifted Hands. So that's the title. Then who are these people who have borrowed this book? Hey, you guys have Psychology of Money, When We Were Asked, Why Africa is Undeveloped. Hey, what? The guys, hey, the suggestion you guys are giving, or you guys are giving the suggestion to just scare us. Hey, the rest of us who never visit a library, we just see it from afar, from a distance. The Diary of a CEO. Hey, yeah. Sinners. Okay. The Subtle. Rich Dad. Hey. Laws of Human Nature. Attention. Rational Male. Hey. Think Big. Ben Carson again. Oh, why good girls never get the corner office? Are you sure you guys have read this book, or are you just suggesting for the sake of suggesting? The Holy Bible. Amen to that. Quran as well. Betrayal in the City. 48 Laws of Power. Okay, hey, I see you have suggestions. After this, I might have to visit a library near me. Hey, there's another one that's called The Art of War. All right. So who are the borrowers? Number one, we can write Abigail, and then John Tefresh. I know John Tefresh never reads. Maybe John Tefresh has just come to collect a book for his girlfriend. There's a son. Then we execute. Let's try to now fetch everything. Oh, there's an error. There is an error. What have I written wrong? Unknown column borrowers. Sometimes having to reference these column names. Oh, it's borrower. Okay, let me just copy the way it is. I remove that S. Okay, cool. Library. There. So we just need to execute this. You see? So, according to you, is this table supposed to be like this? Yes, it has ID. It has achieved the first number form. But why is it that the borrower has multiple value? Why? Like it has Abigail, Jim Fresh, as a meaning, yes, if you're going to a library, multiple people can borrow the same book, right? If John Fresh has borrows the book today and returns tomorrow, the same book can be borrowed by Abigail. Again, the same book, maybe next week, maybe after 2 months, can be borrowed by Hassan. So we need to structure it properly. So how can we be able to structure it? We break this into two, right? We have another table that will be storing what? Borrowers information, and another one for books information, meaning we'll have two table, one for, let's say, library, and another one for borrowers. And then you'll have a one-to-many using a foreign key. Let's say their name. How do you show their whatever? Using an ID to attach. Like that. Like what? Like that. As simple like that. You see? As simple like that. Meaning I'm only keeping it short so that you get to understand. Like, but the borrowers table does not mean you'll only have 2 columns. You can add as many as you want. All right. The same case applies to this. Add as many as you want. The weight of the book, the number of pages, all that. Is there anyone who's still confused with the first normal form? Anyone? But if you are all good, you can just react with a thumbs up. All right. Now, as I had promised, after we do the first one, we'll take a quick 5, and then we come back to finalize. All right? Yeah, let's take a quick 5. Quick 5.
I think you fell in love too fast. African nights and a cool rush. And I remember you refused to kiss me. And now you're using my toothbrush. You say you think I talk too much. That I'm not your type and you don't like the hype. Cause your daddy is a preacher. Now you're wearing my t-shirt. And I don't want this night to end before you know I love you. I don't want this night to end before you know I need you. Na muda usinihishie nikwambie I love you. I don't want this night to end before you know I need you. So I'ma keep it short and sweet. DJ play the song on repeat. Odi dance to the beat. Apolipo kamatana feel so sweet. Apolipo kamatana feel so sweet. Short and sweet. DJ play the song on repeat. Odi dance to the beat. Apolipo kamatana feel so sweet. Apolipo kamatana feel so sweet. Yeah. You wanna do the right thing, you find this too exciting. Your friends tell you kudetum to come in high risk, throw that shit behind me. Come sit beside me. If you got too much class, then do me like a sign.
All right, let's proceed now. We are back. All right, we are back. We are back. We are back. We are back like we never left. Yeah, let's complete. Okay, so also I've already given you another example over here. If you also want to just understand like what is first Like today, I don't feel like using this example, but they are also good. They help you to understand. So let's talk more of the second normal form. Okay. So what is a second normal form? And then we complete the third one. So when you talk of the second normal form, it eliminates the partial dependency. So to make you guys understand this quickly or with so much easiness, I want to use a different, not that this example is kind of difficult. No, it's also very good. But let me just, before we come to that, let's use a different one. Then we'll come to that. We're going to keep it short and sweet. So I'll go to my prior example, employee. And then we say the employee has what? Maybe something like employee name. Department. ID. Their office location. Like that. So what's wrong with this table? We want to achieve what you call the second normal form. So my question will come back to you, right? Remember, we had said that the office is what? Depends on department ID, right? Partial dependency. Do you see? So what will be the best way to do this? Let's discuss in the charts. Like, if I have a table that has this, if I remove this, let's say I have removed this column, and then I maybe just go through only this column, will I be able to get something out of it? Like if someone tells you an office location, the first thing in an organization, you'll ask them, under which department does it fall under? Under which department? Because if you say you're going to the accounts, it falls under which department? Finance, right? So meaning we'll have another table, but now we can choose to create a different table out of this and this to be different, you see? Meaning we'll have two new tables, and now we can reference the two tables. We'll have employee and another one for department. Okay, it's just how you've been designing. Only that I'm telling you, when you design, like how to check, like if your design makes sense. You see, the reason why we are learning this is to see how, when you design the wrong way, how it will affect you, right? That is why last week we learned about relationships, so that you see the benefit of our relationship come into play. Now that we've talked about the partial dependency, if I were you, now how will I be able to, let me remove something here. So let's go to this one. Now, you guys can even give me the suggestion. Okay, give me the suggestion. I want us to make this thing as short as simple as it can be. So give me the suggestion. How do I create the table now? Let's start with the employee or department. Create table. How should the table be? Now I want to see from you now. Because now picture yourself, you're the one who has been assigned the task of designing the two tables. So how would you design it? Anyone? Just type it in the chat. Kimberly. Wow. Okay. Let me go with Kimberly's suggestion because you were very fast. Departments. Oh. Short and sweet. Department. What am I writing? Integer. Primary key. Remember also I said, not always the IDs have to always be integers. You can use UUID and all that. The other thing is department name. Not now. That's the first table. The second table, the employee. Auto increments, and then the emp name, the voucher 100, maybe their address, age, salary, all that. You can store it. And then we don't forget to associate them with the department they fall under. What do we need? We need to have foreign key. Like that. References. Department. Department ID. So the best way to understand this is just by looking how the table has been structured and deciding whether by having that in that table, whether it should be there or it should be in a separate table. You see? So it's this simple. Like you're just designing the table. Like normalization is all about how you structure your table. It's just about how you structure your table. How do you move it from concept, a very nice concept, because you can see like this one, the way we have it here is wrong. So how can you be able to just design that there's no partial dependency? There's no partial dependency, right? That way. Anyone who's still confused? Anyone? How do we get to see the wrongness? Amazing. I love the question. So how do you get to see the wrongness? Before I introduce you to the concept of normalization, you are designing the table properly, right? Meaning, you just have to look at the table and get to decide, like think critically. Why are this column like this? If I have this column in this other table, will it affect the employee? You can see by having the office location. Does the office location talk about anything about the employee? Does it tell anything about the employee? Does it talk anything about the employee? Also, the department ID, does it talk about something about the employee? Yes. Why? Because we need to know under which department does this employee fall under. So you'll notice that the office location here depends so much, right? It depends so much on this one, meaning there's a partial dependency. You see, partial dependency. Like the way I just drawn, partial dependency is just this. Meaning office location depends on the department. So meaning these two will be very nice offset to be in a different table. Like even if I leave it like that, office location, does it tell something about the employee? It's too much info on the employee table, meaning that can be broken down and be added into a different table and we connect them. Like we are overloading the employee table with a lot of information that is not needed there. Can you create many tables at once? Yes, sir. You can create. Me, I'm just showing you. This is the direction. Now you have the powers. You see? It's just trying to like understand a table. Like this is when you get to understand the table and tell them, I don't like the way you've structured the table. How about we have this and this into a different table so that there's a reference? That means we are not overloading one table. At least we've broken down one table, ensuring there's consistency of data. Data can be easily be read about an employee, and we have another separate table about a department that talks more about the department. Okay, so let's finalize with this one. And then we go to the next example. Now, you can now execute. There's something that is on my screen. I need to remove it there. Now, we can now execute and then just confirm. So we have different tables holding different kind of information. We have the employees. Oh, That is not the employee. Oh, yeah, mine is employee there. And we also have the department there. So you can store information about a certain employee, their address, and then under which department do they fall under. When you talk about the department, all we need is the department name, or we forgot to add the location. So you can always use what? Alter command to add an extra column. Yeah, so I forgot to add office location over here. So when you're designing, please make sure it has the specific column that you need, office location. I see why you are getting confused a little bit there. Office location, Bachar 10. Meaning, is it in the first floor, the second floor, the corner office, like the way you suggested for me that good girls don't get the corner office? Is it at the corner? Where is the location of the office? Is it at the corner? Is it in the first floor? Is it adjacent to this building? Or do I need to go to maybe a different location? You get the point now. Are we set? We go to the third one. We call it a day. Are we good? We are coming to that, Juma. Are we good? I want to take you through random example so that when you go to the one that is on the hands-on, I'm going to leave you on the hands-on, you do it alone. All right? That one, you'll do it alone. Yeah, I'm just giving you today random so that when you go through the hands-on, you don't feel like whatever is here is too much. You don't understand whatever is happening. So let's talk about the 3NF. So what's the 3NF? 3NF removes transitive dependency by ensuring that non-key attributes depend only on the primary key. This level of normalization builds on 2NF. I need to sip some more coffee. I'm almost getting choked by my own saliva. Who's mentioning my name? There's someone who's mentioning my name. Please release me from the shackles. Anyway, let's proceed. Now, if you don't know the meaning of transitive, I've written for you very nicely, summarized into your own notes, summarized into how you understand it. Like when you say transitive dependency is when non-key attribute. Okay, another key thing is anytime you see the word, please look, you see this term, just know what you mean is column. Oh, column. How do I write with this thing? I thought I was so happy to get a whiteboard. Column. My nursery teacher must be whizzing right now because the things I'm writing here, just remind me back when I was starting school. This is how I was writing. So the word attributes is another name for column. For what? Column. So it should not scare you. So when a non-key column depends on another non-key column. All right? When a non-key column depends on another non-key column. Let me give you the different example. I want you to go and do this on your own, right? I'm not using today these examples. I just want to make this as short and simple as sweet. We go home. Like today, I want us to start our Friday this early. You know, it's already Friday. For those who know, they know it's Friday. Like Friday has already started. All right. If you know, you know. Friday has already started. Anyone with the next form? If you have a form, yeah, I'm not available. You thought I was gonna say, you invite me? No, I'm not coming to your form. Uh-uh. So, let's design another table over here, and then we call it a day. Oh, and then I release the open source. Okay. So let's design another one. Let me call this student so that we learn this point gets to learn more quickly. Student. So don't take I've designed this table because the day we started like this, don't have this class. Don't have been given a contract to design such a table. And what they did was just come up with random columns and then tell the person who has just given them the contract that the table is now fine. So let me ask you, right? We had already touched on this. This table, at least, it has quite a number of columns. So this is a fitted table. Just pay attention to how it looks. Doesn't it look so much overloaded? Sound is breaking. Let me check my internet. How about now? Is it breaking? Cracking sound. Give me 1 minute. Let me fix my mic. Okay, let me. So, how about now? Is it clear now? Okay, yeah, not that much. Okay, let me try to change then to a different set of. Am I still audible? It's clear. Okay. One, two, mic testing. You can hear me. Still cracking. It's still persisting. What's up? How about now? I believe it's audible right now. Let me put the recording. Okay, just confirm if you can hear me now. Still breaking. Okay, so I've changed to a different set of pairs. Right now, can you hear me? It's good now. All right, so let me just resume with the, yeah, there. Now, as I was saying prior, we have this kind of a table, and now it has all this kind of info, right? So you've designed this kind of table, and just by the look of it, look at how the columns are structured. What are the two columns you can remove? Like, even if we are looking at it, does first name talk about a student? Does it talk about a student? Is it a yes or no? Yes, right? Does last name speak about a student? Yes. Does subject ID speak about a student? No. Does subject name speak about a student? No as well. Does address speak about a student? Does address? Yes. Does age speak about a student? So how can you break this table into multiple tables so that you get something concrete out of it? By drawing this one, subject name depends on the subject ID, like that, right? We all agree. And this one as well depends on that. Together, they form what? They form a chain, kind of a chain. This is a chain. You see? That's a chain. This is what we call the transitive dependency. Are you seeing something? Are you guys seeing something? Is there something that is different? Do you now get the difference between partial and transitive? Is it clear now? Is the concept about partial and transitive clear? Just by going through the example, you can see by transitive, it means this subject name depends on subject ID, which in turn, remember, these are two NaN keys, right? Which in turn depends on primary key. So if I was to design the table, I'll just need to break it into two. And we've achieved the third normal form. That is why, allow me to just digress a little bit. That is why when I was talking about the second normal form, I was saying for a table to be in first normal form, unique values, atomic, all that. And then for a table to be in second normal form, it has to be first in the first normal form, no partial dependency. Third normal form, it has to satisfy second normal form and does not have transitive dependency. You see how simple it is? Good. I see someone saying, can you explain to us how? Oh, this is the wrong place. Now, like it's something that you've been doing. All right, let me tell you how this comes to this. You see, when we say like subject ID depends on the primary key, meaning what you're trying to do, we're just trying to show the relationship between the primary key, meaning if I fetch the primary key, it will be able to speak volume on the student information and the subject they have chosen. So if we were to write this one is A, and then B, C. So meaning A is equals to B. B is equals to C. Transitive, the transitive law. Like this is how simple this concept was. The nuts and bolts of normalization. Yes, Fariz, true, true. It's like the same thing, but you just have to pay attention to how the table has been structured. Is there any other confusion? Are there any other confusion? So if I leave you guys with this example, will you be able to write now to take this, the logic out of this, and then bring it to now the concept into logical steps now. It's simple like that. Like, it's very simple. Yeah, as I said, this was one of that topic which is like closing our eyes. We're just paraphrasing what we've been covering in the previous lesson, where we talked about the various relationship, the one-to-one, the one-to-many, and the various, right? So you can see like how you can be able to testify using normalization. So normalization is just there. It's an add-on. Like, it's not something that you have to consider every time you're designing. It's just something that you have to look at. Like, okay, yeah, how does this table look like? Why is this column here? Why is this? Those are the kind of question I want you to ask yourself. Before we wrap it up, let me just ask, right? Before we wrap it up, let me ask, listen, how does normalization save on space? If you ever ask this, how does normalization save on space? If you're asked today by someone randomly, okay, let's say your friend is John Tefresh. John Tefresh skipped today's lesson. How does normalization save on space? Hey, every day, you guys keep surprising me by how smart you are. Like, I've just got you, we've just we've only scratched the surface on it, but you guys can already understood the concept. Hey, you guys are smart. Today, if I were able to know every one of you, I'd just be PayPaling you. You guys are smart. Yeah, the suggestion that you guys are sending is the one reduces redundancy, like that. Eliminating redundancy. Another one. Say another one. Now, what is risked, okay, if we don't normalize enough? Listen, what is risked if we don't normalize enough? What is risk? What is risked if we don't normalize enough? What happens? Hey, guys, and the way I've been showering with praises. Hey. Listen, okay? Hey, no one is getting it. Hey. Yo. Okay, let's listen to me giving you the answer now. It's simple. It's simple. Number one, update anomalies, delete anomalies, insertion anomalies. And we wrap your class like that. You see? Like the anomalies, meaning you cannot be able to update the table properly. You cannot be able to delete a row. You cannot be able to insert properly. Simple. Just like how a famous man in Kenya will say, I think it's called Atwali. You usually say how? Zimbo, like that, yeah? And we wrap it there. Is there anyone who has not understood? Yeah, simple. Simple. Yes. It's simple like that. That said, I can now take in your question. I'm sure all of you, quite a number of you have a lot of questions. So I'm going to stop the recording. And then for those who are watching the recording, yeah, that's where we ended. So we take in the Q&A. We'll go to the Q&A. Okay, so yeah, open source. Oh,